So what I'm going to talk about is, this is actually several things at once, automating and security tests and Docker and development as part of it. So I'll try to stitch them all together. This talk is intended to be very introductory. It's intended to arm you with enough information to get started on your own learning, or if you know a little bit of Docker, open your mind to the possibilities of using it. Or if you're in a larger organization, know who to talk to in the development organization to start to involve security in a really lightweight way. Rather than running really big tools, Docker lets us run really small tools. So that's what I'm here for. Here's where I came from. I've been doing operations forever. Like I know how to terminate a SCSI bus and stuff. And I've been doing, apparently some other people do too.
Your config.sys.
Yeah. Been doing cybersecurity, well, just incidentally for a long time, but it's only been my job for the last, 3 years. I'm working for a company called Wiz right now, doing cloud security. Before that, I was at Palo Alto Networks, where I was the web application protection specialist. Before that was Puppet Labs, so I love automating things. I think I welcome the robot apocalypse. And PlayStation, I'm in the credits of over 20 video games. It's really fun. So when I beat the final boss, I actually watch the credits. Okay. So here's why I'm here, and here's hopefully why you're here, or here's where you're going to get dragged, is bothering to do this stuff is really interesting to use attackers' tools. They're using this stuff, you might as well use it. No reason to not borrow tools from the attackers. Testing this stuff in development, of course, is an ounce of prevention. It's the shift left story, which I'll talk about in a second. What's really interesting too about doing this stuff in development is developers, you can borrow their knowledge. They know what to attack. They know what the expected inputs and outputs are, where some of the vulnerabilities are. It can be very fun, in fact, to mix some Docker into it so that they're excited, then run a CTF, something like that, see which tools they use, and then now you know what you're going to need to use. And automating to continuously test security is really cool. Scanning things is useful, but you can't just scan and then ship and then see what the heck happens. So if you've got something as lightweight as Docker, you have the ability to spend 3 minutes and just check as often as you like on the security of your application, do a quick test against it as many times as you like. You can even plug it into an automatic monitoring system or something like that. And naturally, the more often you do it, the less you're going to be a gate before production. So if you want to compare, pen tests really do take weeks, Docker takes seconds, and it becomes so cheap that it's second nature. It's easy to automate. It doesn't get in the way of development. And so that's why I'm here to evangelize about that. Who's worked with containers? Okay. Who actually feels at all comfortable with them? Okay, yeah. All right, good. I like introductory groups, so that was about 50-50 there, I think. You can think about containers, and those of you who are really comfortable with them, don't throw things. But you can really think about containers as being just really, really small virtual machines that only do a couple of things, that are just purpose-built. So they're really, really small, which means they can start and stop really, really fast. They're generally pre-packaged. You can make your own, but there's just a wealth. There's a library of container images out there that you can borrow, including ones that have attack tools already built into them. They're single purpose. So you have to think a little bit differently about how you use these tools. If you're used to trying to break web applications with something like Kali Linux, every single thing that you run on Kali Linux is going to be a single container in the container world. So they take a few seconds to run, maybe a couple minutes for stuff like the Z attack proxy. But with that comes the fact that you'll have a bunch of them running 2-3 minutes. However, you can parallelize them and run them all at once for 3 minutes, and then sort of the Smurf army tells you what you need to know. But you can think about them as virtual machines. The graybeards will laugh at you, or worse, but they can really just be thought of as really, really small virtual machines. So a little more kind of technically stuff. This is how Docker itself runs. Containers are I keep scratching, don't I? How's that? I'm going to keep moving. All right. Docker is a particular engine for running containers. And what it does is does the work of organizing these miniature virtual machines and the files that they need and the processes that they need. So we sort of start out in our world with all-in-one systems that run everything. This is like your desktop or a web server that's got a database on it and a web server on it and all of your files on it. And that's been perfectly comfortable space, although it does mean that if you mess something up on it, the whole thing is broken now. So that's kind of one of the reasons why we use Docker and containers, is that there's no need for the other junk and the core operating system itself to be tied together that way. They happen to be tied together that way, but it's possible for me to run applications over here that don't interact with anything else. And all that containers do, and all that Docker does, is says, I want to use the OS without interacting with any of its pieces, so I don't break any of those pieces. I want to run this one application, which might have a couple of dependencies in it, and I want to make sure I have those. I need some files off the disk. I need to connect to the network on some ports, but I really only need to borrow a very little bit of stuff, and don't trust me. And so you end up with just these pieces. This is what gets packaged up as a container, is just enough to talk to the operating system, borrow files from it, borrow its network interfaces, but then stay out of the way. And one of the things, of course, that you could run is a web server. So you could run your own website on it if you feel like it, and then run some attack tools to break this up into really small pieces that run really fast. So why not have my web server here and then an attack here, or multiple containers that I'm going to run that are all going to attack it. I might do some seriously fun damage here, but it doesn't interact with the real system at all. Once I'm done with this, I can just destroy it. I don't care. Those files, that's just a link off to the file system. They don't matter. And so I can just go totally crazy. It's really, really useful for testing of anything at all. So if you're in your organization and you're sort of one of the web people, and you do have developer people and you have infrastructure people, you can find people and borrow their expertise and their enthusiasm for this sort of thing, and say, hey, I was thinking about actually testing my web applications this way, and they'll get excited, I think. The other thing I'll mention that you have to adapt to is that in the old world, what we did was we had one big system that had everything on it. If you broke one thing, it broke the whole system. Containers are intended to be immutable, is the technical term, but they're intended to be built up once. You don't change anything, you don't update software. They just run something for a few seconds or minutes, and then you destroy them. And the interesting thing about looking at web server loads, for instance, is you have to get used to the idea that when you have some problem with your web server or with the tests that you're running, what you're going to do is redefine the whole, here, these 12 containers attack this one container. You're just going to redefine it with new versions of things or new code, destroy the old one, start another one, see what happens, destroy it. So your files, those are going to live in someplace protected. Your network, that's going to be done by the host itself. But your containers, you can't get attached to. You can't FTP into them, and I mean you can, but the spirit of containers is to always rebuild them whenever you need to change something from scratch. Makes things very predictable. It sounds like a pain in the ass, but there's a lot of automation that can be done around it to make it actually work really nicely. Who's familiar with microservices and really adopting them? Okay. These containers really fit into that, serverless as well. The idea that small components should do one thing predictably and interact with each other, and that you should be able to destroy some portion of it and bring it back with a new version. So kind of daunting. That's as far into the deep end as I'm really going to take you. The thing to know is that people are really helpful. I mean, when they are helpful, they're really helpful. And when they're useless, they're really useless. But it's like it's the inverse bell curve. But in the Docker world, you will find people who are helpful. If their README file is, at least has a scroll bar on it, there's going to be somebody's trying to help you. So the README files, take a look at those, try some stuff out. The nice thing about running containers is that you can just try stuff out. It takes 2 minutes, and you're back to normal. So you can try things, and then the thing that I would encourage you is to put in pull requests if you see things that are either functionality that wasn't mentioned in the README file, or if there's a problem there, put in a pull request. It's not that hard to do, and it's really fun when somebody's tool gets better because you made a change to their documentation that made it easier. At the very least, open issues against it. And if you do open issues, it's always really helpful if you offer a solution. So even if you don't want to go into editing the files and doing a pull request, open an issue and say, hey, I think you need this flag to be that flag, not just this doesn't work. But it's a community out there. You'll break stuff, but it's not the end of the world. What I would encourage you to do when you're getting started is actually create a virtual machine in, just a Linux virtual machine in, your tool of choice, and trash that thing with Docker to start with. For one thing, because it's Linux and Docker images tend to be running Linux, it's a little easier to get compatibility working there. There aren't translations going on. Under the covers, Docker on Mac and Windows is actually running a Linux kernel, but they're just not telling you. And that's the sort of obfuscation that I don't like. I'd rather have just a virtual machine that I can throw away, or that I can snapshot, try a bunch of stuff, and then roll back. So it's really easy to be safe about this stuff. And I put embrace destruction on here because that is the philosophy you're going to need to adopt, is the one of microservices, the one of infrastructure that you destroy when you need to make it better, where you just change a line of something, totally destroy the entire website and recreate it. So get used to that kind of destruction and the fact that you can try things safely because they take 2 minutes, and then you know what happened. But so far, any questions yet? Really just the introductory stuff. I'm going to get technical in a second. All right. Well, I prayed to the demo gods and sacrificed a chicken, so let's see what happens. Yeah, let's try it out. We can launch broad attacks. These are all Dockerized, the broad tools. And I did promise you that we can run a web server in a container. And so what I'm going to do here to start with is I'm just going to say, hey, I want to run, and this won't be on the quiz. This is all in the README file. RM says clean up after me. This makes your life a lot easier. I'm going to say I want to run interactively and just create a new Ubuntu system. Tiny virtual machine with too many dashes.
Can you make it bigger?
Yeah, you bet. Oh, yeah, man. Should have asked sooner. All right. And there you go. That was what, like 2 seconds that it took? And now I'm running a system. This is the real power of Docker. And then I can go and I can do things. Let's update. Let's, rm-rf. And when I'm done, I just leave the system. And now it's completely gone. If I run it again, it runs from the base state. And I don't know. I'll just prove to you that I'm on a command line. This is the world of Docker. This is how being able to launch attacks is going to be super simple, also super repeatable. So you don't have to worry that like some cached file in your attack tool decided it didn't need to rerun an attack. It always behaves exactly the same. Plus, they're published out there on the net for you to pull down, or you can publish them internally. And when somebody says, what did you run against this? You can say, this is exactly what I ran. On your system, on their system, Docker is really, it's kind of the formalization of, well, it works on my laptop, into a world where your laptop is that we should just ship it to production. Let me show you another one. Get out of here. Yeah. Let's see. And what I'm going to do, I've actually got the command queued up, and so I'll show you what I'm going to do. I'm just going to run the juice shop because it's cool and it's handy. And I'm just saying, run a container, destroy everything after I'm done, delete the evidence, and then listen on port 3000. Again, not on the quiz, don't worry about it. And then juice shop is the image that I want to run. And away we go, a couple of seconds. It's running. It is still starting up a little. It's probably going to take more like 10 seconds. But there it is. So the real power, and my computer, like the fan isn't running on my laptop. That's the real power. Is I've just started an entire website right here. Works on my laptop. It'll work in production because they're the same thing. And so now I'm really working in production. And let's launch a real attack. So I'm going to use, and this is where the README file comes really in handy. I'm going to run Z attack proxy against it. So I'm running a container, delete everything, all the evidence later. This is the one. And this is the command I want to run once it starts up, which is just do a quick scan. I'm not sure if it's even going to hit any of the juice shop things, but we will find out pretty darn quickly if it does. What the heck did I do wrong? Should have sacrificed 2 chickens. There's a quote there. No path. See, unfortunately, containers also change sometimes too. Let me try a full scan because I also have the command for that. I'm doing something definitely wrong. Here's what I think I'm doing wrong. Give me 1 second here. I'm glad we're recording this. anybody sees what it is, yell it out. I'm sure it has to do with the TTY that I'm pasting. All right. Run, delete, map of volume.
You want to try and run Zap in GUI mode and make sure that the first round of commands are working?
No,
Okay.
I've only got like 24 more minutes. I don't know, it worked on my laptop. Let's, yeah. Mm-hmm. Yep. Yeah, I thought it was. Let me try Nikto. All right, that's a little better. So I obviously messed something up. One chicken wasn't enough. But here we go. Nikto is now going to run, and we'll see what it finds. Now, seconds to boot something up, that's really cool. It will take time for one of these to run. But, see, I got confetti over there. It found one. But I could be running multiples all at once. So I could be running Z attack proxy and Nikto and SQL map and whatever tools are out there. That's also a really fun time to talk with the developers too. Is to say, hey, I've been doing this, and they'll just like go to town on that thing, like anything to not do real work. So it's perfect to just dangle this in front of them.
How often do you grab their UAT, QA, and synthetic scripts and stick them straight into Zap?
Yeah. Well, the cool thing is, if your developers are using containers to build the website, you can run it on your laptop from whatever revision you like. So it'll be exactly the same as what it looks like in production. The uncool thing is that if you aren't, you're going to need your own development environment and deploy into there. Yeah, what's up?
Your previous command that was failing, your current directory has capital letters and spaces, right?
Nice. Nice. That's perfect, yeah. Okay. Thank you. All right. I know that's small. I'll embiggen it in a second. That's a little better. First name. It should be working. So that's cranking along somewhere. And flip back over here. And this one finished as well. And there are some other tricks that I'll teach you too. One of which is that when these finish up their tests, they have different exit codes, which is really just a way for the system to say this succeeded or failed. The Docker containers will actually have different exit codes and say, I succeeded or I failed. And so you can actually automate a bunch of things where you say, hey, run this, and maybe you're writing in a script, and scripting languages will respect the exit codes of tools. And so you can just say, hey, run this check. And if it says there's an error in the run, then go over here and email me. Otherwise, continue and test some other stuff. So this probably had an exit code of, I would guess, 5. I would be wrong. It has an exit code of success. So finding some stuff there. This could be your application. Could be anything. And application-specific attacks, this is where the developers come in handy. And you can actually kind of cheat, too. Because like if you've ever tried to do SQL injection, it does take a lot of work to find all the parameters that are allowed, figure out how you're going to mess with them. The thing is that developers, they have this knowledge, and they know only these keys have only these types of values, and they can give you a list of those. They can say, here are all the parameters I take, come at me, bro. And you can feed that right into SQL map and have a head start and say, okay, I'm only going to bother testing these parameters and messing with them and trying to do injection. Let's try WP scan. And you know what I'm going to do? I'm going to do this. I know why. That wasn't the demo gods. That was me actually trying to go out of order. It was a bad choice. What I'm going to do is, for right now, we've just been running individual containers doing one or two things. In a real environment, if your website is containerized, it's going to be multiple containers, each with its own piece of the puzzle. And if I want to run WordPress, for instance, I'm going to need to have a web server and a database server. Let me show you how that's done in the Docker land. Is love it or hate it, YAML. And the upshot of this, not going to be on the quiz, is this just says I need 2 containers and that they should have that port open and that here are some variables for it. And it makes it super simple to try all sorts of things. I can do a Docker compose up -f. And it just goes and does it. Now this demonstrates when you don't have an image locally. So I've been running off a cache so far. Every time I've run the container, Docker's reached out to the source and said, is there a newer version? This one obviously has a newer version, so it's just pulling it for me. It's kind of magical if you're used to like virtual machine images and things. So it's doing the web server first. It's tethered to my phone, so it'll take a minute. And then the other thing I'll show you is that there are container images that are like real nice Swiss Army knives. So if you are used to running, a Kali Linux system somewhere so that you can break things, there is actually a container for Kali Linux. Heads up, it doesn't have any applications in it to start with. It just has the framework because the goal of containers is to be real small. How are we doing there? Okay. That was pulled. It's finished downloading you. It's setting up the network. It's creating 2 volumes away from the container where I can keep data and it's safe. And I can destroy the containers. I've got 2 of them right here. Anytime I like. And just try again, try over. It's like the ultimate in turn it off and on. Presto changeo. Yeah, there we go. So, I mean, that was like quick enough that I was able to actually wave my hands and dance for a second, and it got done. Like there was no like Millennium Falcon kind of moment there. And so now I've got a WordPress site. Hi, Gabe. That's what I get typing sideways. Let's see. Oh no, that is the password I want. Thank you. And away we go. Okay, cool. So I can mess with this thing now. And what I'll do is I'll run my, here we go. So I'm going to run my WordPress scanner. I've got an API token. I already made that a variable for myself so that none of you gets to know it. I'm still going to revoke it as soon as I get done here. I don't trust you. And away we go. Kaboom. So let's see, it brute forced my name, figured out what kind of plan I'm on. And that whole run took, I don't know, what was it, like 10 seconds. So these are so cheap to do, there's no reason not to throw the entire kitchen sink at a security test when you're developing. Fuzzing, always a fun one to do. That'll take a little bit longer. But there are always command line flags to say, hey, don't go totally crazy. API security, I know, is a big one people are talking about. Definitely fun to fuzz APIs. The thing I'll encourage you to do also, though, is talk with the developers, because they know what they think their API should do. And so you can plug that in and you can say, it should only ever accept any of these things, and do a run that you expect will completely pass as sort of like a start to know that their specification is correct, and then actually attack the thing afterwards. Bit of an acceptance test almost to just hit it. Let's see. Yeah. And then general purpose toolkits, they do exist. We all know them. I mean, we got Kali and Parrot and all those things. As I was saying, they come with very few tools in them, so you're going to have to do your own assembly, and I'll run an example of that in a second. Very versatile, so you're used to, if you're getting used to containers, you're getting used to something that's not versatile. It only does one thing, and the one thing that you tell it to do. These have more of a kitchen sink to them. But they don't start out that way. You'll have to install your own stuff. And I'll show you that. Because I'll show you that with what's called a Docker file and talk about layers. Containers are so small, and you sometimes need to tweak things on them. And so there's a file called a Docker file that you can create that says, give me this container, but before you run it, I want you to do a couple of things like an apt-get install or a yum install. Or I want you to copy some files from my local file system, my web root maybe, into the image, then run it. And if you've dealt with like virtual machine golden images and had to deal with those and then adding things on top, that's really what a Docker file's purpose in life is, hey, I keep running these darn things. So if maybe I find myself running, let's see. Oh, yeah. Ubuntu, you'll do. I have too many dashes again. So here I am. And if I found myself, every time I want to do this, update. And then once I've finished that, and I must be on the ultra wide, install. Nmap, maybe I'm going to do some Nmap stuff. I should only ever, I should write this down and not have to type it myself. Because right now I've taken already 45 seconds doing this, and then, I'm going to run my actual command. Away it goes. What I want is that instantaneous, like let's just go. And that's what a Docker file does. So not going to be on the quiz, but a useful thing to know that you can do. And if you have to learn it yourself, you have to learn it yourself. If you have somebody who knows Docker and knows the continuous integration in the development, which you might, you'll be able to say, hey, I saw this guy talking, his demo didn't always work, but this part did, that he said, hey, I can just ask you to make an Ubuntu image that then updates and installs this thing, and then it just runs a shell, or it just runs nmap www.apple.com. And they'll say, yep, that is totally possible, and they'll do it for you. And what you'll end up with is these are all destroyed at the end. So this is my last one, but it doesn't have nmap on it anywhere. So nothing up my sleeves. It comes back up as normal. My Docker file says, I want a different image, one that runs Ubuntu, runs this stuff, and then freezes it. And this is the command not on the quiz. That just says, hey, let's make this into an official one so that instead of me starting it up, logging in, changing these things, that's not immutable. This actually just gives me a golden image that already does it. And then I can just run that. And now it does have it. So not on the quiz, I swear, oh, there's my coffee. Not on the quiz, but a good thing to know, useful thing to know that as you're learning it or as you're finding people who do know it that are going to help you, that's there. All right. So I promised you some continuous attack. And here's where it gets cool for me. Who's heard the term shift left? Yeah, that's pretty good counting. Okay, good. Because we're all application people. Cool. For anyone who hasn't, the idea of shifting left really is just we have this life cycle of an application where we do some research, we develop it, what did I say? We deploy it, and then it's in production. And that if you consider that to be a right to left progression, if you can get your application security over to the right, towards the research, towards the development end of things, you're way better off. Fixing one problem in development is better than fixing the 100 instances of it that you end up with in production. So that's all we're really talking about. Because this stuff is so small and so easy to run, what we can do is we can actually do this in every stage. You saw me just running commands, just running what was in the README and getting real results. Developers, once you show them the tools, they also can say, hey, I'm thinking about using this container. I think what I'll do first is start it up, like I did with Juice Shop and WordPress, and then run these bunch of other tools that we run here. They're doing it on their laptop, but because it's a container, it's universal everywhere, so it'll be the same as in production, and you can automate your attack. So getting all the way to the research phase is really cool. Development's a little bit easier because version control systems, as you know, can kick off automated tests. Throw these in parallel, and most of the time, the security tests, if they're small containers, are going to outrun the acceptance tests. So that stuff will be done right away. Could even potentially save you some time on builds if they're failing really fast. I think we've all learned that the order in which tests run can be important to put the most fragile ones first so that you fail early. Deployment and production, I would encourage you, since these are such lightweight things, to run them all the time. Your monitoring system could just start a Docker container for 10 seconds, stop, and then report on your monitoring board, on your dashboard, a green light. There's no reason not to. They're so lightweight. You're going to want to share the results of this with the developers and borrow their knowledge. So I'll go slightly evangelist for DevSecOps. Sorry if you're one of the people who doesn't like that term, but I do, and that's a whole other talk. Is that they've got some fun tools that you've never heard of. And you're going to say, hey, I heard I can do this thing with a Docker file. And they're going to say, oh yeah, watch this, hold my beer. So I think we've got lots of opportunities for cross-pollination. For me to say, hey, we thought about using Docker to test our security, the developers to be like, wow, that's shiny and new, awesome. Then they do stuff, and then they're like, what have you been doing? And I'm like, I don't know, I was typing this stuff, but then I had a variable that had spaces in it when it was expanded. And the developers, they help you with that. So borrowing is really, 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 really the spirit here. And here's where I would say to start is to pick a web application. It doesn't even have to be your own, but get something running maybe in a development environment, maybe not. Just do some basic attacks like the ones that I've shown. They're so simple. We already got like 3 confetti cannons out at the juice shop. Let's see what we've got. Still on. But we've already got a confetti cannon out of here. It was a super simple stock test, so that's really easy to do. So don't boil the ocean, but have some fun. Getting fancy, I think, requires you to chat with the developers and say, hey, what's good for you guys? Like, what pieces do you expect to run? What are you acceptance testing? And then saying, hey, we're going to hit those with our tools as well. So get fancy with their help. Definitely integrate into the development pipeline so that you're testing security as a first-class citizen along with testing functions and acceptance tests and what have you. And I do think you should totally integrate it into monitoring. It's so simple. It's one little command, and it doesn't take much CPU. My fan is still not running, and I think it's the wave of the future. Questions? Yeah.
You mentioned talking with developers about parameters when testing the API. Most of our serverless projects now use open API.
Yeah.
So have you seen any tools that will just ingest that?
I have. In fact, the stuff I was working on in Palo Alto does that. So the question was about, particularly with serverless, the developers will have an open API spec file. Used to be called Swagger. And that'll say these are the expected inputs and the expected types and the expected things that'll come back out. There are the savvy next generation tools can take an open API file, import it, and then apply that, particularly to defense, but also should be for attack.
The other thing I just had a comment on, you mentioned your fan's not taking on for Docker. Mine out of the box doesn't use enough CPU or memory or anything like that, so I've gone into Docker and just configured it to use more CPU, and I've found that things work more performantly that way as well.
Okay, all right, so I've been skimping on CPU, but I could have cranked it up. Okay, yeah.
You mentioned using this to keep track of exact testing environments. How do you version libraries and things that you're pulling into Docker? Like when you do an APT update, you're randomly going to get a...
Yeah. What it does is the Docker file itself says what I'm going to do is take an image as my base, run those couple of commands, which could be pulling whatever the latest version is, and then freeze the image. And so you only build it once, and then you run it multiple times. What else?
Making sure you do your NPM audit fix and looking at the standard out to see if the vendor has actually provided an image that has known vulnerabilities already.
Yeah, all sorts of vulnerability tests you can do, NPM and more. And I would even go so far as to say if you have vendors that are doing code analysis for you and you're buying their products, if they can't run it out of Docker, you should laugh them out the door. What else? All right, that's my time. Thanks very much for your attention. I hope you learned something.